Alright. Hi everybody, welcome to the stream. Today we're going to continue the string view refactor going on in my game project. I'm actually not in my game project file right now, I'm in my example project to show off something I was curious about yesterday. I spotted, while I was reviewing the VOD of what I modified yesterday, and I noticed I did something very terrible. And I'm glad I caught it, because we would have found out sooner or later when we ran the code. But let's go to the data file header real quick and take a look at the container that holds all the configuration data in storage. It is located somewhere around here. Okay, right here. I made a mistake. This vector of objects should not be holding a string view and a data file, but rather a string and a data file. The reason being that we can't actually store, in terms of the content, the string itself. Like, this right here is supposed to be the string of the key representing the data file. So it in turn is like another storage container that holds something. This one's fine, this is supposed to be a string, and this one's fine, that's supposed to be a string view because it just gets hashed into a key. So whether you pass in a string or string view here, both get hashed the same way. So yeah, realizing that, the return value for isComment will then become a string as well, because the data passed in will be the same as the vec of objects. So yes. Although we could pass in a string view here, but we would have to convert it, and I think the idea of this function is that it gets used somewhere in here where it's returned from mvec objects. So let me take a look at that real quick. Okay, so yes, isComment is used in here under get ordered keys. So with get ordered keys, we're filtering out an mvec objects. So yes, this needs to be the string itself. Now it's still a view, so it's not really that expensive because it's just looking into the content that exists inside of here. So that is correct. Just one big thing I wanted to point out, and I have my example open here because I wanted to demonstrate how you can't actually store a vector of string views unless the lifetime of the strings that the string views are looking into also continue to exist. So that's what this example is for. Naturally, if I run this and it holds the string views that are dynamically generated, this is just a small loop that generates a 1 to 20 character, or excuse me, 1,000 strings that have between 0 and 20 characters with random letters between A through Z. So we can see here, since they're getting stored in a string view vector and they are dynamically generated, when we look at the contents of said vector, we're going to find that it's full of garbage data, minus the first two. The reason why these two work is because the const char stars, or I guess the strings here, are stored in a memory location in your program. So because of that, these have a direct view into those locations. But for everything else, it's just random garbage data. This is nonsense. The correct implementation or correction for this is to change the string views to instead have the vector store strings. That way, anything you generate will store an actual copy of that string, and you can see suddenly the data is no longer garbled. So, that's just a proof of concept to show that, indeed, if we got to a point where we ran that program, we would find that all these data values inside of MVec objects would have been mangled data values, which is why we fixed that. So that was just a correction I had to make earlier when I noticed that. The next thing we're going to look at is this error we've been kind of avoiding. It's been popping up over and over as we tried to compile. I don't see it right now, but I'm sure it'll pop up again. But we are in the middle of a standard string view refactor where every configuration value in our program is going to handle string views instead of strings. Mostly because I just wanted to try and see if I can convert my entire project to use string views. Now right here, we currently have an _s function, which is supposed to return a string from a configuration file. But we know converting a string view to a string is quite costly, so I almost want to just deprecate this function or completely remove it. As in, the only way to read in a string key from our configuration is via a string view key instead. So I think we'll go with that. So let me quickly find the original _s function. Or excuse me, not this one, but the actual implementation of it. And instead we'll just convert to string view. Now, let's see here if anything has to change. We can see here that we have to generate a string from a const char star anyway, so I feel like we would have done the same in either scenario, right? So can we generate a string view from this, is the question? Get property itself requests a string view. So I think naturally, yes, we would request that. We would just pass it in temporarily, and it would output that for us. I think that's how that works. I haven't actually tried that one before. This says, cannot overload functions distinguished by return type alone. This should be a string view now. Returning that information. Because get string, it does return a const standard string right now. But it's a string reference. But MV content, I think, holds... I kind of want the string view from the string inside this vector, because that's not moving. So in my opinion, we also change this to now return a string view of whatever string is inside of m_v content. I think that will work fine. Yeah, that sounds good. And perhaps get full string would also do the same thing. Retrieves the string value of a property. No, it's got to return a brand new string because it's essentially constructing one. So that one won't work. But yes, _sv is now implemented, and we go back to the location where this compile error occurred, and now we can add together strings and string views. At least I hope we can. Key is a string view. This is a string view. Does this not work? I'm confused. Because that returns a string view. It should be able to be added to this string view. Which should be added to this one. Although, I don't know why it's a const... Well, I guess that's fine. And string view there. No operator plus matches operands string view plus string view. I guess you have to assemble a new string through those, which is kind of interesting. It's like, I didn't even think about that. You can't add two string views together. can you? Because you would have to store it in something. That's fascinating. Okay, in that case, can we, like, standard format it? I feel like we might have to do something like a standard format where we add in 3 variables together, or 4 variables together, kind of like this. Although since these two are already defined, it would look more like this, right? .png. I feel like that's a way we could do it. It's kind of strange, but I think it works. It makes sense to me. I'm just trying to think if there would be any other method to add in string views together. But then again, that doesn't really make sense because you form a new string out of it, so the return type will be different, which is probably why that's not allowed in the first place, because it will inherently turn into a string, naturally. So you have to have something that will convert those for you. That's kind of interesting. Okay, so again, we have to do the same changes to things like this, but then again, we can't add string views together, so once again, we're doing another standard format here, which is just a little different. I wouldn't say it's annoying. I would even argue that it's more readable than a bunch of plus signs to concatenate strings together. But obviously it's a little more verbose as well. So it's just interesting. Where's my... Here it is. Cool. So that's that, and there are more of these that we're having problems with. Item key is a string. Just say this is a string view right now. And we go down here. Equipable class wants an unordered set of strings. So we could convert this to string views as well. That's fine. Sets are also require hashes, so that works out very well. This returns a string view, so we're just going to update this to accept a string view instead. It's also inlined, so I think that's fine. So that should work well. And then we have item conversions, which hold a string. Again, this map can hold string views instead. And then we go down here. Item data, presumably also holding strings. So we're going to see that as we reach into more and more of these data structures, that all the keys are probably just turning into string views now, naturally, instead of strings. So equipable class, again, an unordered set of strings, conversion to string view. Down here, we're doing concatenation again. Looks like it will be this plus a fragment name. So we convert it like so. And then we have the same thing, it looks like. And then the same thing down here. So I'm seeing we have it in 4 places, right? Maybe it's better to just call it the fragment image or something, just to reduce the amount of extra code we're writing. So this could be a const. Well, string views should always be const anyways, because they're essentially references. String view, fragment, image, file name, or yeah, file name. is this. And then we can supply that in here and substitute it in all of these as well. Just to reduce the... we're turning that to a string. Just to reduce the amount of bloat there is there. It looks like this is incorrect though. This should be wrapped around GFX. Dot sprite. Yeah, it looks like I messed that up when I wrote that, or overwrote it. Then down here, we have the same thing. Still. Fragment image file name. And then down here, once again, looks like we have it in a lot of places, so... yeah, then we have what looks to be essentially the same thing again. It's just it's not the file name, but the icon name. So that's interesting. And then the fragment description. Then we go down here. We have getString. And the getString here returns a string view. So is getString here now going to be getString view? I guess so, right? Because if we're getting it straight from the configuration file, then they're all stored as strings. So we naturally get a string view out of it. So I would say so. We can turn this into a string. I'm gonna call it string view now. And I'm just gonna rename it manually. That way we have to go through all the calls of this and ensure that it's working the way we expect. So then getString now returns string views, so this should resolve properly. And then all the calls to it, we're gonna have to go through and manually vet again. Let's see here, this needs to accept a string view. Down here, key is not a string. And add set bonus is asking for a copy of a string, which I find interesting. I think that's a mistake or laziness. But we can accept instead a string view, which probably means sets is also going to need to change to be a map of string views instead. And thus, set name, which is a string view, should now work here. We just have to adjust the definition of this function. And then we're back up here for something. Sets is now adjusted, where add set bonus accepts a set name. Sets is mapped to a string. It needs to be a string view, which we already adjusted. Is it? Oh, okay. That's the actual setup initializer for it because it's static. And then down here, we have a macro. Oh boy. It looks like this reads from getString as well, so... what is going on there? So it looks like if Steam user stats... oh, I see. We just added a wrapper for checking to see if this function even works to begin with, but inside of here, this won't compile if any of these maps, like unlock, is still still uses strings instead of, let me see. So unlock is from data file, data get property, returns data file. So unlock here Weapon max level, get int. I guess the get strings would be the problem. Is there no C string? Let me see. Yeah, there's no C string for string views. Which is kind of unfortunate. I guess we would do, because this is only, well, this is when we enhance an item. I guess that's okay to do a conversion there. It's not a big deal. I wonder if there's a better way to do this. Let's see. Get C string from standard string view. I find that interesting that that's not a thing. Unlike standard string, there's no standard string view C string, which will give you a null terminated character array. Simply do a standard string view object.c string to get a guaranteed null terminated temporary copy. I guess that's the only way to do it, and I guess it's not too expensive, especially not here. If we have to do it on every frame of the game, then I would be very concerned. If you know for sure that you have a null terminated string in your view, you can use string view data. If you're not, you should reconsider whether using a string view in the first place is a good idea, since if you want a guaranteed null terminated string is what you want. Okay, so you have to make sure your string view contains the entire chunk of the string, otherwise doing a conversion to C string might not result in a null terminated string, which means if you read it in as a string, it'll just go on into oblivion and you get trash data. So this returns a pointer to the underlying character array. The pointer is such that the range data to data plus size is valid, and the value in it corresponds to the values of the view. So if at any point the view ends up being shrunk, like you cut off the beginning or the end, then you're going to run into an issue where you're not getting a null terminated string. So it's just more safe to guarantee that's null terminated by converting it to a standard string. And as long as speed is not an issue, like in this function, then that would be the safer approach. Yes, here we're grabbing the entire string, so we know it should be null terminated, but I think being safe here is the better choice. Also, we don't want to cast, we want to initialize. Big distinction there between curly braces and parentheses. I think there's one more get string in here somewhere. Yeah, down here. So we want to do that for here as well. And that should fix that macro. Now we go down here. And we got... Okay, so here we're trying to do get class and return an unordered set. This is probably now a string view because the internal data object is a string view now, or an unordered set of a string view. Equipable class is an unordered set of a string view. Yeah, that should work. Get my class, though, does not return it correctly. Okay. So are we good now? We did not change it, did we? Okay, there it is. Cool. And then down here, we have something similar. We have a get class function that needs to return a string view instead of a string. Okay, so that's done with the item CPP file. Moving on. Still got plenty more to do, but we're making progress. So next in util data file, we have a lot of C string conversions. So this is where it's going to get worrisome, right? Like, this might be where we have to do use the data pointer directly instead. So we just have to confirm that what we get out of this is the full string and not a subsection of the string. So get string here returns the full thing. We know that. So we're going to do .data which will return it for us. But again, we just have to be aware that doing .data means that we're aware that it can't be, it has to be null terminated, or something bad will happen, right? So then we go down here, and we got a couple more. So we got a pushback for vec objects with a string, but this is a string view and a data file. This is for the operator here, which is a pretty, this is a pretty big deal. So vec objects is going to push back a name here. If we're referencing the string view that is located in map objects, we should be good, right? In theory. But what happens? Yeah, no, we should be good, because a vector might resize, but a map objects will not, in theory, right? I don't think you lose the pointers when this happens. Like, it won't be like a reallocation or anything. At least I don't think it would be. I'm pretty sure that's how that works, but we can check. I just want to be certain, right? You never know. So we're gonna go to standard unordered map. So it's an associative container that contains key value pairs with unique keys. Internally, elements are not sorted in any particular order, but organized into buckets. Which bucket an element is placed into depends entirely on the hash of its keys. Two keys are considered equivalent if the map's key equality predicate returns true. The swap functions do not invalidate any of the iterators, which is a good sign that the pointers don't get touched. But they do invalidate the iterator marking the end of the swap region. References and pointers to either key or data stored in the container are only invalidated by erasing that element, even when the corresponding iterator is invalidated. Okay, so that's a good note. The references and pointers will always be valid, or should be valid, in all instances. Unless we get rid of it. Which makes sense. So that's good to know. And because we know that, and vec objects literally is just containing a look into anything in map objects, what I said before about this should be a string, now our understanding internally is that this can be a string view. But I am going to add a comment here about that, because I think it's, if I were to just look at it, I would be like, oh, this is a red flag, right? Because a string view to a vector of string views is usually a red flag of like, oh, how are you going to store that data in there? What is it referencing? The first item in the pair is a mapping to a string from m_v content per the operator hard brace function, and the other function is like set property, I think. Yeah, like any of these, right? Set string, set whatever. Actually, it doesn't do that, which is interesting. It's just m_v content. The operator array needs that in order to read from it. Hold on, I'm confused. Right, because, oh, I see, because it calls it anyways when it does this, so that makes sense. When items get inserted into the map. So that's how that works. Having that internal understanding of that makes it clear that we can do a string view there, and it will be safe. So what I mentioned earlier was actually, I mean, it still applies, it's still true in most instances, but in this case, we can understand that our function is handling it correctly, so we're good there. So we're gonna place back here our standard pair of standard string view, comma, data file. Yes. Excellent. Back up here, get ordered keys needs to be updated yet again because that changed, which means is comment needs to be updated again, which is fine. And then here under operator brackets, we need to do a conversion, or we have to return a string view instead, which is probably going to introduce a lot more errors, so we have to be prepared for that, of course. But that is what it's going to do now. At least in theory. Let me see, get property, string view. That returns a string view, so this should return a string view, so that should be good, right? At least I would hope. Okay, so then we can move on to more. More fun, more operator S's to fix, more everything to fix, honestly. So here, we got a lot of underscore S's. In fact, at this point, I think what we're going to do is we're going to do a global find and replace for this. I think that would be a great idea. I don't know where my window is. Control-Shift-H is supposed to bring this up, but it doesn't. So we're looking for underscore S to replace with underscore SV. So we're gonna find all instances of this. More than 10,000 results? Okay, cancel the search. Realistically, this needs to only be for actual string operators, so we're gonna put a quotation mark there, and that should reduce it significantly. Here we go. So these are all the places where we load up a string from the configuration file. As you can see, 207 matches is a lot. I'm going to see if any of these look strange at all. I want to say most of these don't, but I already can see anything with plus signs is concatenation, and we already know with concatenation, we can't do that with string views, so we're going to have to change some of those to reflect that. We can see here there's quite a few of those, so we're gonna have to go through all this and update that. So all these have to read in as string views, and then we'll do... Now what we could do, I think this would be interesting, what if we write our own string view concatenation function? Would that be nice? I feel like that would be nice, and it just return a string for us, right? I feel like that's very doable and would save us a lot of time, because I would hate to write out standard format a bunch, but how would we write it then? We'd have to say that every plus creates a new string, and I think that's the issue. If you have to do this plus this, plus this, plus this, plus this, each one is creating a new string and combining them together. That's pretty wasteful, isn't it? Unless we make it smarter, like... But each operator plus call is its own individual thing. So yes, if you have a lot of pluses put together, that will actually be costly because you're creating a new string each time. Whereas with standard format, you could do it in one go. I don't know. It's more beneficial to actually write these out proper, right? I think so. So it looks something like that. This would be a string view. That would be a string. Now, if we get strings out of these, which we have to because they're not stored in memory anywhere, then we can pass those along to everything else. So adding all these together should work, right? No, it shouldn't work. I think the IntelliSense just hasn't caught up. Because that doesn't make sense. That shouldn't work. According to all of our rules. Let me check something real quick. How we concatenated stuff up here together. I want to make sure we didn't do something dumb with that string view up here. Okay, so with this, we did get a string out of it, so that makes sense. I just want to make sure we didn't accidentally make another string view out of it, because that would have been bad, right? Okay, so it looks like IntelliSense caught up to us here. So we're going to do, and now it's just immediately gone, which is absolutely hilarious. But yeah, same deal. We're just gonna keep modifying these to reflect that. Here's that. There is this one. Now, if we really wanted to, we could write like get path from configuration value. Like we can see these all use the same pattern, right? So writing a little lambda that does that could be immensely helpful in the future. So down here, this would be a string view. And then in here, we have to do a standard format. Which would be config path plus item directory plus config. Oops. Just like that. And then here, read in the game name. It's a string view. And then all of these. So let's go back to our list of string views that we found. I don't know where the find went. It went somewhere, but let's just find all again. Let's see here. So we're looking for _s, not sv. So sv's means we've already changed them. Yeah, any place that has these pluses, the concatenations, we gotta adjust. So we can see here there's a lot of these, right? I think a lambda is very much needed for this because there are so many of these to go through. So naturally, this doesn't exist. So we have to put string view here. It looks like it's still, a file system still accepts a string view. That needs to be a string view. And then we're gonna write a small lambda here. Let's just call it config path. And we're going to pass in or get config path. Passing in any config name we're interested in. So standard string view. Config key. And then returning a standard format. So this returns a const, oops. This returns a const standard string. Standard format, going to be these two combined together with whatever argument with config path, which we're going to pass in here for the capture. And so it will be config path, comma, whatever config key we have here. But we have to call operator _sv on it. So operator _sv It's kind of strange because usually you don't call it like this. Also, I think it's underscore operator SV? Hold on, I gotta find it. Where are these? Operator space quotation marks underscore SV. That's what I'm looking for. Yeah. And for that you pass in the const char and a size t containing the length. So length, like so. We know the string view is completely null terminated because it's the entire thing, so we can pass in data there. And that should be okay. So with this function defined, we can now just call getConfigPath with whatever the name of the key is. So these are all going to look like this now. And we can do that for all of them. So we will. Let's do a find and replace. You can see there's plenty of them here, which is why I did this in the first place. And we're going to replace config underscore path space plus space with getConfig path, and then replace the underscore s semicolon with close parens or quotation mark close parens semicolon. And that will adjust all of those for us. And then we just have to do a couple of these manually. So that's a string view. This is a... Some of this didn't change, right? Or it looks funky. Like getConfigPath here would mean that originally there was indeed something there. So if I did this, that would work. Although config is a string view, so I still have to combine the two. So that kind of sucks. I guess we'll do that one manually. So 1, 2, 3. Config path, comma, this one. Like so. And then down here we have essentially the same thing, looks like 4 combination values. So we have config path, we have this class directory. Then we have CL, and then .txt is just on its own. Like so. Alright, there seems to be an error with something up here. Let me go back a little bit. Did I miss something? No. Looks like IntelliSense just catching up. Okay, we got this, which needs to be combined with assets. And pack key. I think pack key is just by itself. Yes. Now we are down here somewhere. It looks like this is only from scripting, but we're gonna have the same issues, so I'm gonna take care of that even though this code doesn't compile on this OS. I already know we're gonna have problems with it, so... And we can see it gets converted to a C string. So, luckily, converting it to standard format, we won't run into any issues converting it to a C string. So it's going to be /assets, add in save file path plus system.config. Wait a second. Back up a minute. That looks like that just is on its own. These two are being combined though. Yeah, that was a comma there, so I'm like, oh, that's actually an argument. 1, 2 arguments. So we got that plus this. So that could really go up here. System.config. I assume the save file path will have the slash included, so that should be fine. And then converted to a C string. Let me just confirm I converted that correctly. So originally it was save file path string plus system.config. This is the equivalent of that, just in string view form. Yes. So that looks good. And then we have to convert this one down here as well. So it's essentially the same thing. Right there. Set stage marker probably doesn't accept a string view. So we will change that, which means probably the data structure underneath does not accept string views either. And it will compare to a string, which is fine. And then what else do we got? These two have to be combined. One, two. Well, this one's just here, added to this key. Alright, what's next? There's some errors really far down here. Okay, string views. Map story exists. This accepts a const standard string ref. So change that to a string view. I assume story level data does not, yeah. That needs to accept string views. And the definition of it needs to change to... Oh. There we go. Okay. What else? There's one more a little further down. It's like right around here. Oh. Okay, these two. String views. We got more errors popping up here. Probably now that we've changed some other functions. They're popping up here. Get string has to return a string view. Get string list. We'll be back. It accepts a string key, which is kind of weird. I'm just going to turn the key into a view because get property should accept a view. Yes. Yeah, I'm like, it's kind of weird that it's accepting a copy of a string. I think that's really strange. Same with this one too. Like, why are we accepting copies of strings here? It's very weird. So I'm just adjusting all these to accept string views now. They all run into that same issue. Okay. Alright, we got more to deal with. So the return value here cannot convert that. So data file string data probably needs to hold a string view now. But we have to look and see if that's allowed or not. Because the key, I think, is very temporary. So data file string data will hold a key of its own, and I think it needs to. I think that's by design. Get string list. Yeah, essentially it's gonna return... Wait, is it? Let me see. So what does this do? This holds a reference to a data file. Yeah, what is this for? Concatenate. It iterates through all the values and puts them together. So I called it getStringList because of that, maybe? GetStringList. Versus getting a particular string or getting the 0th item. Get every item. That would be the use case for this. So storing the key is important. So yes, we will do a conversion here to a string, but I don't know where this is actually used. Let's first see where this is used, because it might be slow to actually do this. This is... This is not used anywhere. This function doesn't get used. What about this one? Did I just make these up, but I don't actually use them? Yeah, this doesn't get used for anything. Huh. I'm like, I don't see why I would ever use these. And it turns out that we don't. So I think I'm deleting them. Yeah, why do they exist? Maybe I had an idea of using these originally for something very specific. It looks like it does something super specific, but we don't need it anymore. So these can all go away. Which means those... I think those data structures go away too. Let me look for those data types real quick. Data, file, pool data, double data. Yeah, like what are these for? Why do they exist, right? So there are a couple places where this is used or mentioned. It's used in the class itself. Operator underscore B returns the array itself. Okay, so they are used here. Contemplating string types for 1 hour is peak C++ content. Indeed. Welcome. But yes, this is an attempt at a giant refactor to use string views. There's a reason why I didn't want to ever do this, because this literally changes everything about the project. So we'll see what happens. We'll see if 1, I like it, and 2, if it even works. I mean, it should work, assuming I'm carefully looking at all this, but I don't know if I'll like it. We'll have to see. Internal debate, right? If I actually will like it. Yeah, this is weird. According to this, I guess I'm gonna see if I use this operator at all. Not at all? Nothing found? Okay, what about this one? Or this one? I feel like I made these just for compatibility purposes and then never bothered to use them. Do they have any reason to exist? It doesn't look like it. It looks like there was originally a plan to output an array with them, but they ended up being completely useless. So I'm gonna argue that they go, considering they also have a standard string creation there, which is also strange. So yeah, I think those all go. I think it's safe to say we're done with those. Okay. So what's going on here? These all need to be string views, so I missed one. Okay. Then we got another error down here. Where are you? At least according to IntelliSense, there was something down here, but let's just recompile. But naturally, oh yeah, we're still working on these. That's what it is. So regardless, we're probably a little further in here, so let's modify find and update this, see where we're at. Okay. Player.h. Okay, it wasn't finished. So we've gone down to about here. Yeah. Continuing, pretty much the same deal. Like, I'm just thinking right now, will this ever be a big hurdle in terms of development time or speed? And I want to say not really, but it will be a general improvement in performance when it comes to string lookups and such, which there are quite a lot of. So if anything, at least there will be some speed improvements from doing this, but obviously the requirements to change everything is massive. And there's still a lot of places where we have to concatenate a bunch of strings together, so I guess doing that is like, doing that manually is a pain. But we'll get through it. Somehow. Okay, so there's that one. Key is, I guess, a string view, which we assume map name is a string, but if we turn it into a string view, then I'm guessing the structure that holds the map names is now going to have to change as well. Yes, so map data is now going to have a map with a string view instead. And then here, I was complaining about something, but I guess I missed it. And down around here, there's probably more as well. Here's another one. Oh, we already fixed that one, so that's old. And we have these. Okay. I'd imagine with the amount of strings we've been changing so far, from the looks of it, that this is probably another... This is probably like a 2-day project, from the looks of it. It looks like we'll get through a majority of it today. We do have quite a bit of coding time today. And then tomorrow we'll probably be ready to compile it. That's my guess. So that means we'll probably be back to our regularly scheduled programming. Today is Wednesday? On Friday. Yay! Hopefully, right? Who knows what else will happen? Backdrop name is probably a string? Yeah. that. And four drop. 100 people actually say that. A 4 drop versus a backdrop. I think it's supposed to be called foreground, not 4 drop. I think that's hilarious. Anyway. This just needs to be SV. That probably changes this right here. No, that's good. Okay. Now we're here. We got 4 things to combine. Wait, no we don't. 3 things to combine. 1, 2, 3. Or, no wait, there are 4 things to combine here. Unless I missed something. 1, 2... Oh, never mind. It's just 2 things. These 2 are just arguments for the load resource function. Yeah. Always have to be careful with this. Is standard map string view something valid? Yes, it's valid. Any string views that are sent to a map are just immediately hashed as if it was a string. Yeah, that's one thing that was kind of confusing about it at first. It took me a while to think about, like, oh, how would we ever use string view for a data structure if we have to store it anyway? The memory isn't copied, right? It's just when you say, like, map whatever string view is, that string, the string view immediately, whatever range it is, immediately gets hashed, and then it accesses that member inside that map. So you don't have to store it in memory in order to access a key from that map. Now, if the something is a string view, that's when you have the problem, right? Or if you have like a standard vector of string views, then you run into a problem unless those string views are going to exist for the entire lifetime of that vector, which usually isn't the case. Okay. So yeah, it's a little strange, but that's how that works. It took a while for me to wrap my head around it, and it is a little strange. At first, I looked at string view and I'm like, it's practically useless because anytime I would want a string view, I'm converting it to a string anyways, so I lose any speed or advantage from trying to use a string view in the first place. But then I realized that string views can be put into hash maps. And that's kind of when things changed. Once I realized that, was it actually allows you to essentially access maps without having to store the strings in anywhere but the places you actually need to access them from. So this is a string view. This gets formatted to be 1, 2, 3 .png. Oops. The .png is its own thing. Okay. How would you add something to the hash map though? Do you manually copy it to heap? No, you just add it like you normally would. You access it via the string view key and then you insert it. Whatever you're inserting is not temporary, of course. It'll be copied over. So... Oops, that's not what I wanted. Yes, of course. You have to grab whatever... You have to be able to reproduce that string to access the key again, of course. So... a standard string view that exists, like hello, and like I had this example the other day where I was just messing with it. Like you have another string hello, and then if you string 2, string 1, and our map, right? So it looks something like this, with string views as a key. And essentially you can just think of it as like, whenever you have to access something from the map, the string view is essentially hashed the same way as a string would. So, I don't know, we're just gonna store numbers in here. It doesn't matter what it stores, right? Map. And it would be a map insert, or you can use the bracket notation if you want, but map.insert s1 with, oh, I don't know, let's put the number 4 in there. You can do map insert s2 with some number like 6 or something. Both would work because both end up getting hashed to the same thing, at least we found out. And if you had a string view that had lowercase hello, it would hash to the same thing as this, so then doing s3, comma 10 would replace the second value, so you only end up with 2 keys, even if you have a string versus a string view. In terms of going out of scope, your program should, so you can see hello, comma 6, big hello, comma 4. Insert doesn't actually insert unless it doesn't exist already. I guess I would have to do that to replace it. I think there's also insert or assign. I think that's another thing you can use. I don't usually use it though. So that would replace it with the 10. Regardless if you use a string or string view, because they both hash to the same value in a map. I guess what you're asking is, how does this stay in memory? Like, how does it know what that is? I guess we could test that. Let's do that. So, I'm gonna undo all this because I have an example that just generates dynamically created strings, right? But let's change the structure that holds this to be an unordered map. And again, we'll do string views with a number. And I don't care what I put in here. I'm just gonna put 0. So let's see. I'll get rid of that. That was just testing a string. So this right here generates a 1,000 different strings from like 0 to 20 with random characters from A to Z, and then places them inside the structure. And I suppose we can give them the number of whatever iteration loop they generated on, so it would look like this. So in this scenario, rand string would always become out of scope and not exist anymore after it runs. So Looks like you're right. This actually is mangled memory. All of this is nonsense. Alright, so let me think about this. So... because I realized that once I was debugging, I'm like, oh, I'm actually looking at the names of the keys. So the names of the keys do get saved in the map as well. I guess I never thought of the map as two objects. I always thought of it as one object that gets hashed and the object contained itself. Which means the method I want to use here doesn't work. Because this is essentially what we're doing is these keys we're inserting, yes, they do get hashed and they might get inserting or replaced in the correct values, but then these, you can see here, this map has the same keys, quote unquote, these mangled keys in many places. So we essentially just corrupted our map. Like, this map is completely useless and broken. So that's interesting. I'm kind of glad to realize this now. I didn't really think about that. That's a very good point. Okay, so... I'm trying to think. So changing everything to string views in my game is futile because the structures that hold the string views need to have the strings stored somewhere. Some of the strings are stored because, for example, our config file has that data. So, like, an example, my config file here it works fine in this case because what this does is it has, where are all the variables? Hold on. This is a good use case for a string view because the content is stored in a vector, and then we have two lookups, both a vector of objects which reference a string view connected to some kind of content. Like, this gets linked to a string inside this vector. This also gets linked to a string inside this vector. So this is an okay use for that, as long as the string exists somewhere in memory. But then for a map like for all these other maps I've been changing, right? Like right here, this backdrop data, yes, I can do string view to display what the file name is for this renderable, but then when I do it again, it might not exist in there anymore. String views are probably the best thing to pass to function args, since you can pass a C string literal and it won't copy to a temporary standard string. A C string literal. Really? Let me see. That's interesting. Windows gave up. I don't know what Windows is doing right now, but it gave up. So... I guess my biggest issue is that a lot of times all my structures are standard strings. So if I have to save something into a structure, I have to convert it to a standard string every time. So that's always the issue, is that everything... My project has so many standard string dependencies that anytime where I think a standard string view would be useful, it turns out it just gets converted back to a string anyway. So there's like a lost optimization there every single time. Like, on the surface level, it sounds great, but I can never find a use case for them. And every time I try, it ends up just going back to being a string anyway. Okay. So, I do have an issue now, in that I think some of our string view stuff was started yesterday, so I'm gonna have to pull back the git commit I did yesterday and remove anything else I started on. I don't think we did much, but I think we did some basic stuff. Obviously, everything I did today gets undone. And then we have to look at what we changed yesterday. So yesterday... Oh boy. Oh boy, oh boy. Yeah, it wasn't as egregious as today's, but we're gonna have to go back. So we're going to reset to this, to this commit. And now we can use this as a reference to everything we need to look at again. Or maybe we go the other way. I'm not sure which way to go. I think it's better to go from this commit and remove all the things that we've changed. I think that makes the most sense. I don't know if there's a fast way for me to get to... Okay, there is. But it's a temporary... Okay, it created a temporary file of the new file. But then I have to go and find the actual file myself, which I guess is fine, and adjust these myself. So it would be something like this. So changing that back to a string, for example. Audio. Hello? Where's audio? I don't think it even opened. It just ignored opening. There we go. Add event volumes. Was accepting a string view. So this is what I mean, right? Like, sure, it would have been nice to pass in a string view for, like, the name of something, right? That seems very reasonable to do. But then we get to add event info here, and it's trying to insert it into a map. And if the map is not does not have a string view for a key, this is invalid syntax. I have to convert it to a string anyways. Why am I using a string view in the first place if I just have to do that anyway, right? Like, this happens every single time I'm trying to use a string view, so I'm thinking there must be some fundamental misunderstanding of why a string view can be useful. If you do standard format in the function, it's still useful. But I would argue that's still constructing a new string, right? And that's essentially the same thing as spending extra CPU cycles to do that. And there was one point where I did that enough where my game actually slowed down and I realized, oh, I'm doing this every frame. That's actually a really bad thing. We don't want to be constructing strings all the time when we can just pass a reference to it. Yeah. I've been having trouble trying to figure out, okay, where and why, where and how can we use string views such that we don't have to do copies? Because copying eventually has to happen somewhere in the process of adding it to your structure. So your program would have to be designed in a way where every structure that wants to hold these strings and let you use string views everywhere, all that has to be done initially. That is true. You can just use string views when you have to manipulate string stuff. You don't have to copy around more strings. Like, for example, a lot of that string concatenation I did earlier, some of the like string manipulation stuff could probably be reduced with string views. I think that's a good argument for it. I don't know. I'd have to really start a project with the intention of using string views to really start understanding how it's useful. Because every time I've tried, I've ended up in this situation or a similar situation like this. And once again, we're here. So I've done this like at least 20 or 30 times now, because every single time I've tried to do the same thing, not necessarily convert my whole project to using string views, but trying to use any string view parameters anywhere. Every single time I've had to revert it. So yeah, I think it's just a cost of, or the result of starting with strings everywhere, right? I think that's the case. I think I can actually go through and just say, hey, copy paste this old file in, because I think if everything in here is old, just copy paste. Why am I changing it individually, right? That doesn't make sense. Okay. Yeah, because I have... Right now I'm doing const string refs when I could be doing const event refs, I guess. So I want to at least restore it to its original state, which would be nice. Okay, these... So anything related to monster strategies, that's fine. That actually should be done, because we shouldn't be copying strings anyways. So that was okay. Let me just make sure that's still in there. Yeah. There were a few I found where I was actually copying strings, so I'm just like, that's weird. Why are we doing that? So we're gonna undo this. That's a monster. Defines. This we just got rid of. That's okay. Do nothing. Wonder what this button does. Oh, that's neat. That only shows me changes. I like that. That'll be useful for this. Okay. It won't be useful for copy pasting though, I believe. Let me see. Will it do it? Oh, nice. It does. Okay. Well, that's handy. Okay. Environmental audio. It was kind of my fault for trying to combine two feature changes that are unrelated to each other at the same time, so that's my mistake. I just have one commit with two things in it. I think I just got lost in the sauce yesterday. So let's start. Let me think what actually kicked this off, because I was looking at something. Something made me say, oh yeah, we're gonna kick off string views because of X or Y. I need to look at what caused me to say that, because this wouldn't have cascaded into what it was if it wasn't for me looking at one particular thing and being like, oh, I can string view this now. So we were adjusting monster strategies. That's all well and good. I was happy enough to do that, and Everything was going great. I think it's the strategy names. I'm pretty sure. Let me see here. Because I think I looked at that, I'm like, oh, let me just pass a string view here. Right? I bet that's where it all started. String view strategy. Yes, that's where it all started. Because string view strategy is going to do a lookup into that map. So that's what kicked all this off. And that was in runstrategy.cpp. And yes, this structure right here, monster strategies, was where I decided, okay, I'm gonna start doing this. And it all went from there. So I'm like, oh, okay, well, this is storing the name, but then the strategy, no, it was something else. It was the strategy name going into these guys, yes. So I'm like, okay, I'll pass it in via string view, that's fine. But then I realized, let's see. So passing it in as a strategy here means that when I call run strategy in monster, I guess this is a good demonstration of why I can't use string view at all, because this will show like how this turns into, oh, I'm gonna have to do a conversion at some point and everything starts going to hell, right? So all our strategies call run strategy, which calls this function, which passes in the name. The name is a string, but the function accepts the string view, which is fine. That's an implicit conversion. But then anything else that would need it would need to be passed in via a string view. So I don't know if I did this, like right now it seems okay, because name is a, I don't have IntelliSense right now because it's, my project is a little in a poor state, but strategy function itself, the name is a string, so that is fine, being passed in as a string view parameter. Run strategy just needs the enum. So this was okay. I think I got another idea to start changing more things. Maybe from the config. Maybe. I'm starting to think maybe that's where it came from. Anyway, let me continue to do this, and then we'll see where we're at. So I did environmental audio. That's done. I did item. Did I miss something? Giant octopus? No. Okay. So yes, item got a major change. Let me undo that. I think I spent the last like hour yesterday making these changes, so luckily undoing them is very fast. Okay, item enchant. Thank you for pointing that out, by the way, before I went 6 to 8 hours deep into this and realized that everything just fell apart anyway, and I would have to start over. Well, not start over, but go back. I guess I just didn't really think about that. It made me rethink how maps work, I guess. Because I didn't really think about the second, well, the key object, which has to be stored as well. I guess just internally, it needs to be hashed to figure out what buckets it would go into. Like, if I were to design a hash map, then yeah, I would use the object, obviously, to figure out what buckets to put it into to make the finding of the object faster. in the map, but that doesn't necessarily mean the object isn't required. It itself still needs to be stored in there. And I thought more about it, I'm like, yeah, how do we retrieve the object from the map? Like, you can iterate through all the keys if you wanted to. How is that possible? Well, obviously you have to have access to the object. It's not just all hashes in there. Why would we touch mini... Oh! That's hilarious. I actually did modify mini audio by accident. Yesterday we did like a find and replace on all the double semicolons with single semicolons, because I think I screwed up the find and replace earlier. So that actually touched all these infinite for loops. Well, not infinite, but for loops with no conditions. Which I found one in my project as well, so I replaced that, not thinking maybe other people use this syntax too, which is absolutely hilarious. So that's funny. I was like, why is mini audio giving errors? That must be a cascading error. There's no way mini audio, a library I didn't write, could possibly have problems, right? Haha. Little did we know. We actually did touch it. That's funny. I'm like, wait, we're in mini audio, how's that possible? Alright, monster. Okay, so spawner list is not a thing anymore, so that will still go. I think most of this is set. I just have to see if there's any, like, string views. So there is. So we put string view in here, which, again, phase... I think this is where it all started, right? Because I'm like, okay, well, why don't I try using string view in other places? I think it was harmless in using it down here. Well, we don't even use it down here, honestly, but... I think it was harmless to pass it into the strategy functions, but then I started changing it elsewhere, and that's when the problem began, because phase comes from the names of the strategies, and the names of the strategies come from my configuration file. So then I changed it in my configuration file, and everything messed up. So I think this is where the cycle all began. So I need to go in... Oh, that's not right. Or is it? It's not quite at the bottom. Well, run strategy is, but... Where's our string views? Because we need to replace those. So get modded stat bonuses needs to go here. This is the one where we have to do some changes individually, unfortunately. Strategy name. So is strategy name now a string view? Is that what happened here? Because I think that's what's... Yeah, okay. And that's... That would be fine until I have to modify phase, right? Once I need phase, I need to convert strategy name to a string, and this is AI, monster AI code that runs every frame, so I can't be constantly looking this up via a string view, because this map requires them to be converted to strings. So that's always the issue, is like all my lookups would be inside a hash map that stores strings. It's like if there was some way to be able to read the string keys as string views, that would be great. Because I think they hash the same, which is fantastic, but they aren't accessible in the same way. Which to me is weird, but there must be a way to do it, right? There's gotta be a way to do it. Because that wouldn't make sense. I don't know, it's weird. But yeah, this was the reason this all started, was because I'm like, oh, I'm gonna pass in the string views of the strategy names, and then I realized it's incompatible with my map, so we can't even pass the monster strategy names as string views in the first place. Yeah. It really defeats a lot of the potential savings that I think string view has, which is unfortunate. Oh, okay. So it's almost like you did what I tried to do just now, thinking you could get away with it. Ah. Darn. Well, that sucks. Okay, anyways, I found basically the source of where this all started. So everything changes except for this line here. So I guess let me unsummarize this so we're not confused. So that goes away. Everything after this, we're gonna just copy paste because we can. So that goes into monster. Let me just find that line real quick. Where's run underscore strategy? Everything from here down replaced. And then the monster header, likewise. I think the monster header is fine minus these functions I changed. Or the strategy name, yeah. So we can go back on these. Yeah, let's just say everything from here down should roughly be what I want. Probably got to fix like one or two more things, but that's roughly where we're at. Okay. Monster strategy helpers. So this is where I changed it to string view, so I'm gonna put it back to a string now. And then NPC. I think that was it for that file. Let me make sure that was the only change. +8. Yes, there's more down here. The define strategy stuff. Which, that's fine. Okay. I'll go get some sleep, have fun. As much as one can have fun while fixing C++ string handling issues. Thank you. At least, I appreciate you at least pointing it out, because that saves me quite a bit of time. In another universe, I would be doing this without realizing that was going to break everything, right? So, yeah. Thank you. I hope you have some great rest. Thanks for tuning in. Oh, man. Okay, that's just a typo. Did anything else change in here? No. I'm actually gonna leave that because that is a typo. This file probably has a bunch of string view stuff we have to undo. Yes. So back to that. So, for maybe my 5th or 6th time, I've talked about this. Why we don't use string views? Because they never work out. There's always some point where you have to do a conversion for them, and so they don't really get much use in the ways I would like them to. There are some niche uses, but they're so niche that they rarely see the day of light. But most of the time in my game, I can't just pass them in as I please through parameters, because it just doesn't work out, ever. So run strategy here. This is all fine. Up there, I just have to change these back to normal. So that is run underscore strategy. I feel like one day we will finally find a use for him. Maybe. Just maybe. One day. But this is a good lesson again. We've done this lesson a billion times now, so unfortunately we've done it again. Shifar, okay. Looks like I've modified this as well by accident. It's the CPP. Okay. Stone Golem, Stone Elemental Turret, version, that's fine. And run right. Okay. So, if we've done everything correctly, we have reset all of our files to the state it was at before we started making any changes to string view. I'm just gonna first do a clean build, and we're gonna see where we're at, because we've been shaky for a little while. Too many include files. Oh no. Audio includes itself. How is that possible? Well, that's funny. How did that happen? Oh, I put the CPP file in the header. Well, that would definitely do it. So this is supposed to be the CPP file. I'm gonna undo that real quick. Wait. This didn't undo. Hello? Undo everything, please. Okay. And everywhere we use string view has to be replaced. So go back to that commit. We need to pull the changes one more time. And it was audio.h that we messed up on. Copy, paste. Okay. And then audio.cpp. All right. I think we're okay. Recompile, please. I'm like, include file inclusions, like self include filing would be very strange. Alright, so we're in the middle of compiling right now. Okay, so I'm seeing some string view to string errors, so that will pop up in a second probably. And we're just going to be fixing those, because naturally we've found out we can't even use string view in the use case we want to, so that's got to go away. Alright. Let's start here. Insert no overload member function could convert all argument types. It's doing that const monster strategy int thing again, so we have to specify what it is we're adding specifically. Let's see here. Because I put strategy function, but apparently it's not getting the memo. Strategy function. And this insert is our custom insert, so it should be doing... It shouldn't be recognizing that as an int, at least I think. Maybe it doesn't recognize this. Do we have to... Am I gonna have to, like, cast that? It's kind of weird, right? I don't know. I don't know if that's actually